This is question number 9. We're told that A, B, C, D is a parallelogram whose diagonals intersect at the point E. We're told that if A, B, and E are the points -1, 0, 3, -2, and 1, 4, then find the equation of the line DC. I've highlighted that in yellow down at the bottom. So the question wants us to find the equation of this line here, DC. In order to find the equation of any straight line, we need the gradient of the line and one point lying on the line. So right now, we don't have any points on the line. And normally, if we want to find the gradient, we would need 2 points on the line. But the fact that this shape is a parallelogram means that this top line, this top side AB, is parallel with the bottom side DC, the one we are interested in. And what we know about parallel lines is that they have the same gradient. So if we work out the gradient of line AB, then that gives us the gradient of line DC. So that's what we'll do first. So writing down the gradient formula for the line AB. So first of all, I should point out that this diagram is really only for illustration purposes. It doesn't serve to represent the actual parallelogram. So substituting in our points, well, remember it's points AB we're using, so y2 is going to be -2, and we're subtracting y1, which is 0, and that's divided by x2, which is 3, take away x1, which is -1. So -2 take away 0 is -2 on the top, and 3 minus -1 is the same as 3 plus 1, which is 4. And -2/4 simplifies to -1/2. So now we have the gradient of line AB, which is the same as gradient of line DC. So we have the gradient of the yellow line. What we need now is a point on the yellow line. Now I've highlighted this point D as the one that we're going to work out, but I could have easily tried to work this one out. The thing that's going to come in handy here is the fact that we know this point E. We have a diagonal, which is a straight line connecting B and D, where B and D are the endpoints. The midpoint E here we know is 1, 4. And what we normally have to do in a situation like this is work out the midpoint using our midpoint formula and the 2 endpoints of the line. But what we can do is using the same formula but working in reverse. Instead of working out the midpoint, if we have the midpoint and one of the endpoints, we can work out the other endpoint. And that's what we'll do here. So putting down our midpoint formula, and we have x1 plus x2 over 2 and y1 plus y2 over 2. This time x1 and y1 are going to be 3 and -2, but x2 and y2 are going to be unknown because those are the points, the coordinates in point D. We already know the midpoint E is 1, 4, so we can put that down to begin with. x1 is going to be 3 plus x2, which is the x coordinate of D, this point here, so we'll call it xd, over 2. And y1, which is -2, plus y2, which is the y coordinate of D, so we'll call that yd, and that's over 2. So what we could do at this point is look at each bit separately. We have 3 plus xd. If we divide that by 2, then we know the answer is going to be 1, because we have it already. And we have minus 2 plus yb. If we divide that by 2, we already know that the answer is going to be 4. So what we could do now is we could write down working for that. We could set out two equations, 3 plus xd over 2 equals 1, and minus 2 plus yd over 2 equals 4. We could then solve for xd in our first question and solve for yd in our second equation. If you think carefully, you could probably do it in your head though, so if you feel the need to write down the working, that's fine, but we'll go ahead and try and do it in our heads. So if we consider the first one to begin with, we know that this part, when we divide it by 2, we're going to get 1. So what do we need to divide by 2 to get 1? Well, we need to end up with 2 on the top, so that would be 2 divided by 2, which would give us 1. So how do we end up with 2 on the top here? Well, we have to have 3 plus something to give us 2 on the top. So that means 3 plus minus 1. 3 plus minus 1 is 2, and 2 divided by 2 is 1. So that means that the point xd, or the coordinate xd, I should say, is minus 1. If we think about the next part, we've got minus 2 plus yd over 2, and that's going to be 4. So something on the top divided by 2 gives us 4. So that something on the top is going to be 8. So we have minus 2 plus something has to give us 8. That something must be 10. Minus 2 add 10 gives us 8. So that means yd, the coordinate, is equal to 10. So we have minus 1 for the x coordinate and 10 for the y coordinate. That means the point D is the point minus 1, comma 10. So now we have everything we need in order to work out the equation of this line. We have the gradient of the yellow line, and we have one point on the line, the point D. So I'm going to clear some of this working away so that we can write down our equation of a straight line formula. So keeping the important information, we have the gradient is minus a half, and the point we need is minus 1, 10. So writing down a formula, y minus b equals mx minus a, where this is the point of the a, I should say, and this is b. So we have y minus 10 equals minus a half, and then x minus a, which is x minus 1. So we can simplify in the bracket here. Our two minus signs give us a plus sign, and we have a fraction here, so we want to get rid of that. So if we multiply everything through by 2, the fraction will disappear. So multiplying everything by 2, that gives us 2y minus 20 equals minus 1, and our x plus 1 in the brackets. So our 2y minus 20 stays as it is for the minute. Minus 1 times the bracket is minus x and minus 1. Gathering everything to the one side, so we'll bring everything to the left. We have 2y minus 20. Our minus x becomes plus x, and our minus 1 becomes plus 1, and that's equal to 0. Our minus 20 add 1 gives us minus 19. So we have 2y plus x minus 19 equals 0, the equation of the yellow line DC.